Hey, welcome back, Marauders. In this video, 3.1 chemical equations, we're going to look at balancing equations, writing chemical equations, and talking about why and how they need to be balanced and get a little bit of practice with that. So first of all, what are chemical equations? They are equations that describe what happens during a chemical reaction. So during a chemical reaction, you have reactants, which is what you start with, products is what you end with, and during the reaction, the atoms break apart, they break chemical bonds, they rearrange themselves and form new ones, and those are your products. The equation should be balanced because of the law of conservation of matter. So law of conservation of matter, things aren't being created or destroyed. If you have 5 grams of reactant, you need to have 5 grams of product. If you have 5 atoms of hydrogen, you need to have 5 atoms of hydrogen at the end. Again, when you're going from reactants to products in a chemical reaction, the identity of the atoms is not changing. It's just changing how they're connected and how they're arranged. So like I said, balanced equations need to have the same number of each kind of atom on each side of the equation. And so that's what we'll demonstrate right here is how to balance an equation. Pretty simple equation. Methane and oxygen react together to form carbon dioxide and water. So this is a combustion reaction. Methane is natural gas. A lot of people use it to heat their homes. We use it in the lab for our Bunsen burners. So what I'm going to do is just list out the elements that are present in this equation. Carbon, hydrogen, and oxygen. And then I'm going to count how many I have on each side. So on my reactant side, I have 1 carbon, 4 hydrogens, and 2 oxygens. Product side, 1 carbon, 2 hydrogens, and 2 plus 1 more, so 3 oxygens. So the carbons are balanced, that's good. The hydrogens are not, so I need to balance the hydrogens. So looking over here, I need to get 4 hydrogens on this side. I can't change this subscript 2 right here. That would change what the substance is. It's H2O because it's water. If I made it H4O, it wouldn't be water anymore. I don't want to change what the product is. I just want to change how many of them I have. So I'm going to put a coefficient, a number out in front, to show that I have 2 molecules of water. Within each molecule, there are 2 atoms of hydrogen. So when I do that, that changes me to having 4 hydrogens on the product side, so that's good. That also affected my oxygens, so I have 2 oxygens there, 2 more right there, so that's a total of 4 oxygens on the product side. In order to get 4 oxygens on the reactant side, I'll need to put a coefficient of a 2 right there, and so that's how we get 4 oxygens on that side, and then everything's balanced. So that was a fairly easy one. Just demonstrating that same thing in a picture here. So we have methane, which contains the carbon that's here in the center, and then it's surrounded by 4 hydrogens. Those 4 hydrogens end up in these 2 water molecules, so 2 separate molecules, each containing 2 hydrogens is where the 4 hydrogens end up. The carbon comes over here and ends up in the 1 molecule of carbon dioxide. And then we have 2 molecules of water, 2 molecules of oxygen. Each oxygen contains 1 atom of oxygen, so there's 4 oxygen atoms total, and they end up right here, 1, 2, 3, 4. A couple other things you're going to see when you're balancing equations. You're going to see these symbols from time to time. So S stands for solid, L stands for liquid, G for gas, and AQ for aqueous. Just gives you a little bit more information about the states of matter. It doesn't change anything that you're going to do when you're balancing the equations. Just gives a little additional information. You also need to know what diatomic molecules are. So diatomic, that means 2 atoms in a molecule. So these 7 elements, they're always found in pairs. Hydrogen atoms never exist on their own. They always pair up with another hydrogen atom if they're not bonded to something else. So it's pretty easy to remember these because they're all sort of together on the periodic table. Well, you need to remember hydrogen's over here, and then the others are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these 6 are kind of together over here, and then hydrogen. When you see those in an equation, they always need to be diatomic, 2 atoms in a molecule. So let's practice balancing. That's the only way you can get good at this, is to practice a little bit. So we have another combustion reaction right here. We have carbon, hydrogen, and oxygen. On my reactant side, 4 carbons, 10 hydrogens, 2 oxygens. And then on my product side, 1 carbon, 2 plus 1 more, 3 oxygens, and 2 hydrogens. All right, so let's balance the carbons first. So I would need to put a 4 there to balance the carbons. That affects the oxygens as well. So now I have 4 times 2, that's 8 oxygens, plus 1 more, so that's 9. Hydrogens, let's do those next. So we have 10 on this side, we have 2 on the product side. So I would need to put a 5 in front of the hydrogen, or in front of the water, so it's 5 times 2, that's 10 hydrogens on each side. And now we have, how many oxygens on this side? 4 times 2, so 8 in the carbon dioxides, and then 5 more from the oxygens. That's a total of 13 oxygens. So in order to get 13 oxygens on this side, the coefficient I would need to put in front of the oxygen, since it is diatomic, it's O2, I would need to put the coefficient 13 over 2. 13 halves times 2 would give me 13 oxygens. And so technically that gives me the same number on each side of the equation, but I don't want to use fractions. I want to use all whole numbers when I balance the equation. So I'm going to temporarily do that, and then I'm going to go through and get these to stay in the same ratio, but to be all whole numbers. So I'll multiply them all by 2. So 2, 13, 8, and 10. And then the equation will be balanced. Down here, practice another one. So here I have calcium on my reactant side. I also have oxygen and hydrogen. I'm going to notice here that oxygen and hydrogen are together as hydroxide. They're also hydroxide over here on the product side. And then I also have phosphate and phosphate. So rather than writing those each out as individual elements, I'm going to keep those together as polyatomic ions. You don't have to do it that way, but I think it'll make it a bit easier. So we have hydroxide, we have sodium, and we have phosphate. So on my reactant side, 1 calcium, product side 3, hydroxides 2 hydroxides and just 1, sodiums 3 and 1, phosphates I have 2 and 1. All right, so let's see what we can do. Balance the calciums first. So we need 3 on this side, so we'll put a 3 in front there. That changed my hydroxides to 3 times 2, 6. So we'll do the hydroxides next. So if we have 6 on this side, we need 6 over here. I'm not going to change the formula again. I'm going to change the coefficient in front. So that's 6. That changed my sodiums as well to 6. So to get 6 sodiums on this side, I'll need to put a 2 here. 2 times 3 gives me 6 sodiums on each side. And then that changed my phosphates as well. I have 2 phosphates. And then looks like the whole thing is balanced. These are a couple where we need to do word equations, change them into formulas, and then we'll balance it. So here we have solid potassium chlorate is heated and it decomposes to form solid potassium chloride and oxygen. So potassium chlorate, it's an ionic compound. Potassium has a +1 charge. Chlorate, ending in ATE, it's a polyatomic ion. You need to know this one. ClO3 with a -1 charge. So potassium chlorate, it's a +1 and a -1 charge. So KClO3 is potassium chlorate. It decomposes to form potassium chloride. So this one ending in IDE, that's just the single chlorine with a -1 charge, potassium. So that'll just be KCl. And oxygen gas. Remember, oxygen is diatomic, so it's O2. All right, now we can go through and balance it. So we have 1 potassium on each side, that's good. 1 chlorine on each side, that's good. 3 oxygens and 2 oxygens. So kind of a common pattern when you have 3 and 2. You're going to need to put a 3 here and a 2 there. Notice that I got all the formulas correct first for the compounds. I'm not going to change the formulas. Now I'm going to add coefficients to balance it. When I put the 3 and the 2 there, I changed some of my other elements as well. So now I have 2 potassiums and 2 chlorines. So I'll need to put a 2 there to balance those. Magnesium hydroxide, ionic compound. Magnesium has a +2 charge, hydroxide a -1. So a good formula for magnesium hydroxide, MgOH2. Don't forget to put the parentheses around your polyatomic ions when you have more than one of them. Hydrochloric acid, so really common acid, HCl. It makes magnesium chloride, so magnesium from the periodic table we know has a +2 charge, like all the alkaline earth metals. And then chloride, like all the halides, has a -1 charge when it forms an ion. So MgCl2 and water. All right, so now we're ready to balance it. Let's list out what we have on each side. So we have magnesium, oxygen, hydrogen, and chlorine. On your reactant side, you have 1 magnesium, you have 2 oxygens, 2 hydrogens plus 1 more, so 3 hydrogens, and 1 chlorine. Product side, 1 magnesium, 1 oxygen, 2 hydrogens, and 2 chlorines. All right, so to balance the chlorines, we need to put a 2 here, and that gives me 2 chlorines on each side. Doing that changed my hydrogens. Now I have 2 hydrogens plus these 2, so that's 4 hydrogens on this side. So I need to get 4 hydrogens on this side. By putting a 2 here, I can get 4 hydrogens on each side. And then that changed my oxygens as well. I now have 2 oxygens on each side, and the magnesiums were already balanced.